Okay, so we are recording. And I want to say good morning. I want to say a couple more things about getting ready for the quiz tomorrow. One of the things is this, the 1-5, I'm going to give you in the breakout room, I'm going to put you in breakout rooms and just it's going to be a quick thing. I just want you to experience it. But while you're in there, have an opportunity. If you look on As You Learn, there's a breakout room practice problem I put there in under week 3. And the idea is there's a couple of problems. One of them has to do with section 2.1, and the other one has to do with section 2.2. I'm going to include that kind of question on the quiz tomorrow. So in a minute, I'll go through these problems after we return from the breakout rooms. I'll go through the problems. But in the meantime, I'd like you to stop and think about it. While you're in the breakout room, I'll ask you to introduce yourselves, just say first name, whatever, and just say, hey, it'll be brief, but I'm going to go around to each group. So could take a couple minutes. And as a result, and if you have time, feel free to take a shot at, talk about what would you do to solve this problem? What would you do to solve these two problems? One is from 2.1, and that's the one that's f prime of c, which is saying, what is the slope? In section 1, the very beginning of section 2.1, the definition is f prime of c is the slope of the tangent line at c, at a specific point. Okay? Well, when you get to the 4th section of that same 2.1, they now start calling it the derivative at c. Okay? So the notation is going to be talking about derivative. When we go to 2.2, all we're finding is the derivative at the point. Tell you what, let me put you on my iPad really quickly, and I want to show you this. So the idea is that there's two distinct things, and I'll ask you something about this later. So the very top here is the statement that came from 2.1 that I'm going to ask you on the quiz tomorrow, and that is to find the slope of the tangent line at x equals c. This is the formula you use, and this is on that problem sheet that I just gave you on that other situation, okay? So it's going to ask you, so the formula is you take f of x, the limit as x goes to 1, and I'll go through this problem in just a minute, okay? But you guys can work on it yourself when I put you in the breakout room. Stop and think what you think it might be and try it. Now, 2.2, look at the difference here. This is called the derivative of a function. And this is the answer is a function, all right? And as a result, this is the derivative of this function at any point on the function. The answer is going to be a function, okay? This one, you're going to get an answer, and the answer is going to be the slope. Whatever the slope is at x equals c, that's what the slope is going to be on this graph, at x equals 1. On this one, you're going to get an equation, and the end result is going to be, it's still going to have an x in it. Usually it will. If it's a line, the slope is always the same. So if you take the derivative of a line, the answer is going to be a number because it's the slope, always. But if it's anything bigger, x to the second, x to the third, whatever the larger the power is, or a fraction, or whatever you've got, then the answer is going to be a function. That is a function also. So if you got f prime of x, if you had a line, if the line was y equals 4x plus 3, then the slope is 4. And the answer will be the derivative is 4, is the answer, always. It's always 4. Well, like if you have a function like this, I'll do the problem again in just a little bit, okay? One other thing I want to mention before I go into that, I want to put you in the breakout room just a second. But before we do, I want to say I'm going to ask a couple questions from 1.5 also. And that had to do with what's the limit as x goes to infinity of 10, okay? So get those patterns down. Remember, if you've got a rational function, if the exponent's bigger on top on the x, then the thing's going to take off to infinity. If the exponent's bigger on the bottom on a rational function, you end up with 1 over x when you're done. That means it's going to 0. So make sure, and if it's the same, if the exponent is the same, it's going to go to the constant that you have out in front of those values. We'll talk about that again in just a little bit. Look back at the 1-5 problems. And listen, you guys, I took a quick look at how many people have been looking at the sapling problems, okay? And there's a handful of you that doesn't look like you've opened it at all right? And you don't have to. Up through 1-5, you've gotten full credit. But I really, really encourage you. A lot of you have done all the problems, and you've got a little advantage there. I really commend you. Those of you that haven't tried the problems, you really need to get your hands in there and get your hands dirty and get ready for this thing, all right? For this test, so there's about 7 or 8 of you that haven't done any of the chapter 1 problems. And make sure you do that. Again, it's not a mark against you, but it's just that it's not using the tool. Get familiar, use it, practice, get familiar with the stuff and get it under your belt stronger, okay? So
I have a question.
All right, so this is what I want to do. Any questions? Katie, you got a question?
Oh, yeah, I do. So I know you said the 1.1 through 1.5 homeworks, those were like given. Is it now being graded at 2.1 and up? Like, do you get what I'm saying? Is the homework from chapter 2 now being graded? Like, it's
Yes,
not given?
that is correct. The 1.1 through 1.5 are still up, and the due date I put on it is the test date, okay? That is next Thursday. But you got full credit for them. 2.1 and 2.2, there's 16 and 14 problems. There's 30 problems. Now you need to get 21 of them in order to get 10 out of 10. Everybody's got 10 out of 10 on the chapter 1 stuff, okay? But on chapter 2, you need to get 21 out of the 30 in order to get 10 out of 10 on chapter 2 stuff. So take your time, make sure you follow the instructions, listen to the hints, don't use the last try. You get 3 tries. Don't use the last one until you feel pretty confident that you got it, okay? If you want to wait until you get with me or verify it, we can do that. But the goal is for you to get an understanding and make sure you use it as a learning tool in a good way. All right, on the sheet, okay? Number 1 was asking you on the sheet that's on the page there. It's on the As You Learn site for week 3. It says breakout room practice problems. And the idea is the first one is saying, this one is saying, what is the slope of f at x equals 1? The word derivative. What is the derivative? What is the derivative of the tangent line? What is the slope of the tangent line at x equals 1 to this graph? That's what it's saying. And what we're going to be saying overall is, what is the slope? And we're going to call that, what is the slope at this point, which is referring to the tangent line at that point. The slope of that tangent line is what we'll be calling it. And that's the main idea we're working with. But if it's a curve like this is a parabola, So the slope is changing all over the place. So when you take the derivative of it, when we do this down here, it's going to be a variable. There's going to be a variable in the answer. So the answer can change. The slope's going to be different for the whole graph. On this first one, we're saying, what is the slope of the tangent line at x equals 1? All right. So the idea is I want you to use this formula right here. All right. This is c at x equals 1. So x equals 1, 1 is c. Therefore, what I need to do to solve this problem, I'm going to do it right now. I'm going to use my magic pen. And the idea is now I want f prime at c is equal to 1. All right? And that's going to be the limit as x goes to 1 of f of x. I don't plug the 1 in there. This is the original function minus f of c, which is f of 1 over x minus 1. Right? So so that's the change in y over the change in x. Remember what we're doing with all this stuff. It's the slope. It's the rate of change. All right. So I need f. So up here, I need f of x, the limit as x goes to 1. The limit sign is still needed. I haven't plugged 1 in to x yet. So I've plugged in 1 to c, but the x's are still in there. So f of x is the function x squared plus 4. F of 1 is 1 plugged into that function. So I've got to subtract 1 squared plus 4 over x minus 1. So I still haven't taken the limit of, and that's x squared plus 4. And what do we have in there? 1 plus 4 is 5 minus 5 over x minus 1. And that equals, again, let's go one more step, of x squared minus 1 over x minus 1. Okay, now you're to a point of recognizing. Typically, the situation is going to be that that denominator will factor into the numerator. It'll cancel with the numerator, a factor of the numerator. Okay, so factor that out on top. Now we've got the limit as x goes to 1 of x plus 1 times x minus 1 over x minus 1. X minus 1 is common. Therefore, remember, there's a problem at the very beginning. The denominator, if we plug x in, 1 in for x, we get 0 in the denominator. Until that goes away, it's still a problem. Now it goes away. Now the situation is, what's the limit as x goes to 1 of x plus 1? Okay, now I'm plugging in 1 for x, so lim goes away. When I plug in 1 into the function for x, lim goes away. Therefore, the limit as x goes to 1, well, that's going to be 1 plus 1, which is equal to 2. So that is saying that the slope f prime at 1 is equal to 2. The slope of the tangent line at x equals 1 is 2. All right? Now, real quickly, let's go through the second one and we'll call it a day and I'll let you ask your questions. This next one now, remember this. This is the limit definition of derivative. This is in section 2.2. This is at the beginning of section 2.2, the definition. This is written as a definition. And the way it reads is, let me read it to you. I could call the text up on my screen, but I think I don't want to take that time. But it says it blatantly. The derivative function f prime of a function is this. This right here. That's the derivative function, okay? And that turns out to be now, it's going to be the slope at any point on the curve. It's going to have an x in it. So it's going to be variable and the slope's going to be different at different points. This function right up here is a parabola. You know, the slope, as you go around all over the place, the slope is different on the tangent line all over the place, okay? So what we've got to do here, remember this now. So f prime of x, the appropriate label, the derivative of our f of x, which is this function right here, okay, is equal to the limit, and I need this limit, as, oops, that's h goes to 0. Sorry, typo. I knew I needed an h, but it's h goes to 0. Critical. That let me focus on it and make sure it's clear. This is different because the denominator now is no longer x minus c. Notice you're not subtracting. You got x plus h minus x. So all you have left is h. Okay, so now we need f of x plus h. The original function, which is something squared plus 4 with x squared plus 4, with x plus h stuck in there instead of just x. The original function is x squared. Now we need x plus h squared plus 4. This is f of x plus h right here, minus f of x, the original function. over h. And now you guys remember this, you got to multiply this thing out. This is, I'm going to go ahead and acknowledge, you remember, instead of writing over the limit as h goes to 0, you can put a smiley face there. After you've written it one time, you can do that. But now you got to multiply this x plus h squared, which is x squared plus 2hx plus h squared plus 4 minus x squared. This original problem was plus 4. So now I get, notice I noticed that my 4's didn't cancel. So I knew something was wrong. So we got a minus a plus 4, which gives us minus 4. Now my 4's will cancel over h. Okay, so check that. Make sure you copy it down wrong. You got to get a flag go off in your head. Make sure you have something go off and let you know if something's wrong. Okay, so what do we have? We got x squared minus x squared. We got 4 and minus 4. We've got, now I'm going to rewrite this as lim, as h goes to 0, of 2hx plus h squared over h. H is common. Remember the goal. When you do this, the denominator goes away. It'll cancel out. And therefore you'll be able to plug in 0 for h, but you can't until the denominator goes away, okay? So you end up with the limit as h goes to 0 of h times 2x plus h over h, cancel, cancel. Now we've got this. The limit as h goes to 0 of 2x plus h. And if you want to, you don't have to repeat this. I'm putting it in to make sure you all see it completely, okay? But this, make sure you show me significant steps. Limit as h goes to 0. Now I'm going to plug in 0 for h, so I don't need lim anymore. That's equal to 2x plus 0, which equals 2x. Okay? So this is saying that the derivative function, which is the slope of this function at any value of x, is equal to 2x. Notice what happens. Go back to the first question. We said, what is the slope at x equals 1? Plug in 1 into 2x, what do you get? 2. And that's the answer we got here, okay? So you get confirmation of that. Also, real quickly, let me just go on Desmos and show you the two functions, 2x and x squared plus 4. Real quickly, I want to hit Desmos and clear this stuff off. And let's do x squared plus 4. And the other, the function.
We're still seeing the iPad.
Okay, thank you. Good call. We've got that initial equation was, what's the slope of the tangent line? It's 2, right? Slope is 2. What is the point? The point at x equals 1 is, you plug 1 in, you get 5. So what we've got is, I'm going to bring this down here, m equals 2. The point f of 1 equals 1 squared plus 4, which is 5. So our point is 1, 5. So I've got m equals 2, the point is 1, 5, y equals mx plus b. Y equals m x plus b. What's b equal to? 5 equals 2 plus b. B equals 3. Therefore, the equation of the line is going to be y equals, the slope is 2 plus 3. Now, if I plug this into my function back in Desmos, I'm going to go back there and look at me one more time. Look with me one more time. The equation of the line is 2x plus 3. And look at that now. You can check for yourself. The line touches the graph at one point. And the point is, let's zoom in here. Ready? Zoom in here. The point is what we got back there, 1, 5. The point is 1, 5. That's where the equation of the line, y equals 2x plus 3, touches our graph, x squared plus 4. That's verification to you that you got the answer right, okay? So if I ask you to find the slope That's one question. Then to write the equation of the line, you need the slope and the point at that point, okay? So, any questions about that at all? Okay, I'm gonna go ahead and stop recording.